All right, guys, welcome to the Fiveable NMSI AP Reader Chat for AP Environmental Science. It is a crazy additional night in quarantine for everyone. I don't know where everyone's coming from. It's 6 p.m. Central where I am, but if you're coming from the East Coast, stay awake. We're going to make it. We promise this. We'll keep this as engaging as we can. My name is Matt Wells. I teach down in the Houston area. I've been an APE's reader since 2012 and do some consulting for NMSI around the country and some other groups. And we also have Kristen Shapiro co-hosting as well. Go ahead and introduce yourself.
Hey guys, I'm Kristen. I've been teaching APES for 10 years now. I am, like Matt, I'm an AP grader, so we're the ones grading your essays. I also write some of the multiple choice questions that maybe you've seen in your AP classrooms. And then we also do lots of work with NMSI, kind of training other teachers and working with students kind of around the nation. And we're both just so excited to be here to help you guys and to kind of steer you on the right path for your upcoming exam.
This year's exam, there will be some content, but it's been very clear from the College Board that what they're going to focus on just for this year only is these science practices. It's these skills that you've been learning. You maybe didn't even realize you were learning them throughout the year, but it's these things that are to do with scientific thinking, science process skills, how to analyze text, how to analyze data, designing experiments, reading a graph, making claims, stating evidence, conclusions, all of that. So I think that makes it a little easier for you guys because it means you can really focus your practice and your preparation on those skills that we know are going to be targeted on this test. So Kristen and I are going to do our best to kind of talk you through the kinds of skills and practices you're likely to see on your first free response question and then the ones that you're going to see on the second one. So let's just kick right into the very first free response question. This is the long one, right? This is the one where you've got 25 minutes to write and then up to 5 minutes to submit that so that it uploads. This is where you're going to either design an investigation or you're going to analyze an investigation and pull out the things that are listed down here in the bullets where, yes, there'll be some environmental content. So you have to describe some concepts and understand some problems and things. But the main focus of this question is being able to think scientifically, to be able to design methods to research a problem or to look at a protocol that somebody has done and pull out the parts of it that really matter, those components of the experiment. So let's just get a look at some of these. This is where they fall on these practices. You'll notice there's some concepts. You've got practice one, which is those environmental explanations. You do have to know some stuff. But remember, it's only over units 1 through 7, so you don't have to worry too much about water pollution and some of the global change things. It's going to be more focused on other areas, but you will for sure have visual representations, probably on question 1 and certainly on question 2, where you'll have a graph, a diagram, a model, something to look at and analyze. And then this question, FRQ number 1, is really focused on practice 4. And you can see all these bullets in there. It just details out exactly what you've got to do. You've got to identify hypotheses, identify variables, identify research methods, analyze them. You've got to criticize them. You've got to evaluate them. You've got to think about how data might be collected, ways it could be improved, modifications. That's really the focus.
I think that the important... Oh, sorry, Matt, will you go back one more? I think the important thing about the investigation is it's going to ask you some pretty straightforward things. You know, for example, what is the independent variable or what is the dependent variable? But then they're also going to ask you to think very critically about the experiments. They're going to ask you to say, was this a good way of doing it or would there be a better way? Okay, so it's not just you identifying the parts of the experiment, it's evaluating, like Matt said, and analyzing. So I think somebody asked us a question earlier, what does it mean when it says to analyze, like the verb says analyze? They're wanting us to give kind of like pros and cons and then tell us what is the best one. Like the best way of going about this experiment would have been to do X, and this is why it is the best way to go about it. I think that if you're just going to say, oh, this is the independent variable and this is the control, you're probably going to earn some of the points, but you're probably not going to earn all of the points.
Mm-hmm. Yeah, you'll have read and have noticed from some of the updates from College Board that these are meant to be ungoogleable questions, right? They're not going to ask you something that you can just quickly open a tab and say, oh, there's the definition for that. That's my answer. You really are going to have to think, analyze, and apply. And so we'll talk you through some examples of ways you could do that. And then, of course, the other part of these experimental design questions is they often do have some sort of data analysis component, not necessarily a data table or a graph to analyze, although that can happen. It's often you having to think about, well, what kind of data would I collect? How would I know if the data supported the hypothesis or not? What kinds of data would lead me to reject a hypothesis? What kinds of modifications could I make that would result in different results? So you really do have to apply it. So if you think about that, none of those questions could be Googled, right? It's all scientific. But there will be some freebies in there, like where it says practice 7 here, environmental solutions. There'll be some content where you may be able to quickly check your understanding, get your notebook out, find that definition of, wait, what was that again? What is ozone and why is it bad? Okay, I remember. So you may have to do something like that, but I would say in terms of points, the majority of points are not going to be for that kind of content knowledge. What do you think, Kristen?
I 100% agree. If the College Board has made it very clear that most of the information is not going to be something that you can Google. And if it is something that you can Google, you're going to run out of time if you think that you can just Google all of the different parts. They're very, very long. So I think that, you have to have some content knowledge going in to say, okay, well, I understand this component of tropospheric ozone, and therefore I'm able to analyze this data. Okay. If you need to look up something quickly for reference, absolutely, it'll be there. But I think while Matt's kind of getting there, we go. I think the other part of the environmental solutions is it's going to ask you to do the same thing. It's going to ask you to justify the proposed solution. So say, okay, I've looked at this experiment. This is what my data is saying. How would I fix that? And what is the best solution for fixing that? And sometimes that's information that you may be able to look up, but that justification is really what we as readers are reading to say, hey, did you copy that off the internet, or is that something that you truly understood? College Board is screening for you to just copy and paste off the internet, but it's really going to be that justification. Why is that the best solution, or why does your experiment suggest that this is the way to go? And that comes from being able to analyze the data or interpret the data.
Yeah, we really want to see your thinking on this stuff for sure. That's how you'll earn points. If you can show your thinking, that's how you're going to earn points on this kind of question.
Yeah, so again,
go ahead.
When it says to analyze, that really means give both sides and then say which one is kind of best. I don't think you're going to see a lot of analyze. I could be wrong, but that's not usually a traditional verb that we see. But they might ask you to explain, and then they might ask you to justify. So justify is really pick the best one, and why do you think it's best?
Yeah, they may ask you to propose a possible reason for this particular thing, and then you'd have to back it up, just exactly like Kristen said. But there will be an experimental design component where you will need to think about how scientists do their research. And this is where you're really looking at ways to control variables. That is the main goal of experimental design, is how can I manipulate these natural phenomena in such a way that I can really target the one thing I'm interested in. Like what is the effect of this particular fertilizer on this particular plant? I want to make sure that I'm targeting just this particular fertilizer, and everything else is controlled, right? So that's the overarching goal of experimental design. It's the hardest thing to do in science, is to eliminate variables, control variables, and focus on the one thing you're interested in changing, and then the one thing that you're interested in measuring. And so here they are. Here are these variables. And I can tell you, every single experimental design question I have ever seen for APES or for other AP content areas has always required students to have a deep understanding of these two things. And they're the same two things that need to go into your hypothesis that we'll talk about in a minute. So you've got your independent variable and you've got your dependent variable. And these have other words. You can see the other names. They're manipulated variables, another name for the independent, and then the responding variable, which leads to this idea of dry mix, which we'll talk about in a minute. You may have heard that. But I like to think of the independent variable as the thing you're changing. That's what it is. I'm going to change this and see what happens. What happens? Well, that's the dependent variable. That's the effect that I'm going to measure, because it's going to respond to the change that I made. And then you've got these, you have
Yeah,
a
like I like to
control
tell
group.
my students, right?
Go ahead, Kristen.
Oh, sorry. I tell my students that I is for independent variable because it's what I am changing, and then the dependent variable is what's going to depend on what I am changing.
Yeah,
so I don't, and you know, like this is not this chart that we put up here. You are allowed to have your materials out. And so I might encourage you to screenshot this and to print it out, or to screenshot it and write it out on a piece of paper in your own handwriting so that you can quickly just reference it. Sometimes when taking your test, you'll know stuff in your head, but it'll just make you feel more confident if you just look and be like, oh yeah, you know, I'm right. And therefore you can move along. You want to make sure that you're getting all of the possible points. And so getting those what we call like low-hanging fruit, like easy points from identifying the independent variable and the dependent variable is important, because it's what's going to stack. It's going to help you build up your points values.
It really is, because if you have a good understanding of these two things, it means you're also going to have a great hypothesis. And so there's points for both of those. And also you'll have an understanding of whether your data supported it or not, and what kinds of changes or modifications to this protocol could result in different results. So yeah, these two things are probably the two critical things. A control, now this is where some students do enter into problems here, because the control group is different from this idea of controls. You want to control all of the variables that could influence the outcome of the experiment, right? And that's really what a variable is. It's anything that changes during the experiment. You've got to make sure you control them all, including the one that you are going to manipulate, right? So it can be a little confusing to think about, well, what the heck is a control? In most experimental design setups, you have to have a comparison group. And that is what we mean by the control group. So you have your experimental groups, and then you have your control group, which is your normal conditions. That is the thing you're going to compare everything else to. Let me just go backwards a little bit here. And this can be tricky. And as you're designing your setup, I'm remembering back to the last real experimental design question that we had back in the 2012, number 3, was the last one we had in APES. It required students to design a setup to test the effect of a pesticide in the water on some minnows. You may have done that as a practice question. And students, when they were designing their protocol, they had a good control group, but they had this kind of either-or setup, where there was the control group that had no pesticide, and then they had another group that had pesticide. And that did not earn them points for their setup, for their protocol, for the description. Because in order to have experimental groups, you need to change the amounts of your independent variable. You need to show that there's a directional relationship between what you're doing and the response that you're going to measure. And so that means you have your control group where you don't do anything, and then you gradually increase or decrease whatever your independent variable is with multiple amounts, so various degrees of change. So you have several experimental groups and one control group.
Sometimes it's easiest if you remember 5 by 5. So you're going to have 5 levels of that independent variable. So let's say we're going to go back to Matt's example where we were testing a pesticide, and you obviously want to have an area that has no pesticide, but then maybe we have 4 other tanks, right? And they have 5, 10, 15, and 20. So total, we have none. That's our control. That's the thing that's most like normal conditions that we're going to compare it to. And then we have 5, 10, 15, and 20. So we have 5 what we call levels of our independent variable. And then the other place that sometimes, we're going to talk about it in just a minute, the other place where students sometimes lose points is they forget that you should repeat it. It's not just a one and done. So we say that we want to have 5 levels of independent variable, and we want to repeat it 5 times. We call it a 5 by 5 design. So if you want to make a little note that that's something it'll just help you remember, okay, maybe your experiment has to do with plants, right? The very classic example of growing plants with and without light. Well, maybe you're going to do no light, sunlight, a blue light, a red light, and a green light. So those are my 5 levels of independent variable. What's most like normal? Sun. So that's my control. And then all of the rest of them are my independent variable, my level of independent variable. So 5 by 5 will usually help you get all of your points.
Yeah, it's a good tip. I saw a question here in the question group here is how to write a hypothesis from JB, and we're going to get there. We're going to talk about exactly how to earn your points. Because on that 2012 question, very few students earned the hypothesis point because of what the College Board was looking for, but you're about to find out what the College Board is looking for. So for example, let's just get a look at this little question that's up here right now. You've got this scenario where you're a farmer, you want to test crop yields. What would your independent and dependent variables be? So this is wide open, right? There's no structure to this. This is a very, very wide open problem. You're a farmer, obviously you're interested in increasing crop yields. What would you do to increase your crop yields? What might you test? So go ahead, and if you're in the chat there, go ahead.
And remember that there are multiple right answers to this, and that this is an opportunity for you to learn. It's better for you to say something wrong here and us to be able to fix it than for you to just kind of go through and not have a great understanding. So we're looking for you to say, what's your independent variable, what's your dependent variable, and put them in the chat.
Yeah, go ahead and do that while we're just hanging out here. And that's a good point. What Kristen just said is absolutely right. There are many ways to earn these points with experimental design. They're not looking for a cookie cutter approach. You could do 3 experimental groups or 4 or 10, and you could change the amounts by increments of 2, 5, 10. It really doesn't matter. What they do want to see is that you've targeted your independent variable, controlled everything else, and you have a control group for comparison. As long as you've got those things, you're going to earn those points. All right, anybody going to put anything in the chat here? Let's see if anybody's feeling brave enough to answer this question. What might you select? There's no wrong answer here, really. As long as you know the difference between independent is what you are going to change, and the dependent is your variable, is your response. So I see Robert Smith is putting here, independent variable, amount of pesticide use. Perfect. Independent variable could be amount of water. Awesome. And then the dependent variable will be crop yield. Thank you. Yeah, that's perfect. Now, I will say this. What would you measure? And with these hypotheses and with your protocols, it's important you think, how am I going to measure these things, right? How am I going to measure out my independent variable, grams, milliliters, what kind of units, what am I going to change and how am I going to measure it? But it's even more important with the dependent variable. How am I going to measure this response? Yeah, lots of great answers coming up in the chat here. These are all things that are measured. Amount of sunlight, amount of crop use.
Yeah. So I think that a lot of these are really great answers, right? We're seeing the amount of sun when you go on, you further explain, how are you going to control that? You can't like turn the sun down. So while it is a correct answer, we just want to be specific. Maybe that means you're going to use a shade to limit how much sunlight is moving in or out. So just be very specific and thinking through, how would I actually do that? But a lot of you guys are on the right track, right? The amount of pesticide that you use, amount of fertilizer, amount of water. And then as Matt said, your dependent variable is your crop yield. But are you going to measure that in terms of like how much vegetables are produced? Are you going to measure that in terms of how high your plants grow or how wide your plants grow? So we left this one pretty open, but just some things for you guys to think about as you're planning it. You have to tell us, remember that as readers, we don't assume anything. Everything that we grade has to be written on that paper. So you need to tell us exactly, how are you going to measure that? So Josh tells us, okay, we're going to measure that in terms of biomass. And so I would say that that's probably acceptable on the AP exam. I don't know how many farmers are out there weighing their actual biomass, but it would be a way for us to measure our dependent variable. And so we're absolutely on the right track with that one.
Yeah. So let's talk about hypothesis, since this was one of the hardest points to earn on 2012. It is usually given in an if-then statement. It doesn't have to be. There are different ways you can write a hypothesis. But the key thing in all of the different strategies that you use are that you have got your independent and your dependent variable are identified in there, and they're both directional. So if our independent variable in that last situation, let's say it was pesticides, if the independent variable was pesticides, then you would say, if the amount of pesticides is increased, then the mortality or the number of deaths in the minnows will also increase. So you've got both the variables there, your independent and your dependent, and you've stated a direction for both of them. And that's why it was really hard for folks to earn that point that year, because some folks would say, for example, if you increase the amount of pesticide, it will have a negative impact on the minnows. Okay, so you've increased the amount of pesticide, that's good, but then what about the dependent variable? it will have a negative effect. Well, how are you going to measure a negative effect, right? You can't interview the minnows and see if they're sad or depressed or unhappy, you know. How are you going to measure that, right? You got to have some sort of measurement, and it needs to be directional, right? What's going to happen to this effect? Will it be positive and negative, and what sort of direction is it going to go in? So that's really the key thing.
So Matt, we had a question in the chat, and
Yep.
it kind of just goes with what you were saying. Somebody just asked us, did your answers have to be reasonable? And I would say that, and this kind of just goes with what Matt says. You can't ask a minnow, well, did that negatively affect you? And have them be like, oh yeah, I'm depressed now. It has to be reasonable in terms of what a scientist would actually do. Like, the fish is obviously not going to respond to you. So you're probably better off with saying, and so the fish is going to die. You can't, when we say it has to be reasonable, it can't be like too much of a burden for somebody to actually do. So one of the common responses we see is, well, how might you fix this environmental problem? And students always say, well, we're just going to ban it. That is not reasonable. Okay. So when thinking about it, don't try to find the like loopholes and be like, well, but if you did this and did this, then you could do it. Yes, but that you're probably not going to write that on your paper, and we don't know that. So don't put that down. Go with the most straightforward, first thing that comes to your mind, fits the science answer. So when I say, Josh put that we're going to measure biomass, it's not reasonable for farmers to measure their biomass. I mean, they have hundreds of acres, but it's very reasonable for a scientist running a controlled experiment to measure biomass afterwards. So just kind of keep that. I don't really know if that answers your entire question. So don't pick something that's kind of like random and off the wall. That's probably not going to earn you points. But very streamlined, very mainline answers are going to be a lot more acceptable and reasonable.
Yeah, one of the key things to remember about a hypothesis is that it is a scientifically testable statement. So when you're writing out your hypothesis, think, could science answer this? Could science provide the information that would allow me to say, yes, this is true, or no, this is not true? If science can't do that, then it's not a good hypothesis. So if you've got something that's not easily measurable, chances are it's not a good hypothesis. So always be thinking about, can I measure that? Can I measure this manipulation to the independent variable? And can I measure the response in some way? How would I measure that? And as long as you've got that in your hypothesis, chances are you'll be able to earn that. So it's two things. So it's making a prediction about the relationship between these two variables. So it's got your independent and dependent. And then it's also stating a direction for each of those. And both of them need to be measurable and reasonable. So I think that probably answers your question. So moving on then, once you've got your hypothesis there, you've got to think, okay, if I'm targeting just this independent variable and I'm measuring the response, well, what else could influence this? What else could affect these plants or these minnows? Those things are going to have to stay the same. And that's where we run into this terminology issue sometimes. You can call them controls because you're controlling them. A better term is probably constants. And I like that word because it really says what you're trying to do. You're trying to keep them constant. You are going to make sure that they don't change, right? The amount of water, the temperature, the time, all of those things that could certainly influence the outcome of your experiment. You don't want those to change in each of your experimental setups. So it's good to think of those variables, the other things that could influence the experiment, as constant. And then it's also good to think about, as Kristen said, 5 by 5 is a good way to go because it lets you think, well, how many setups do I need? And then to think about the validity of it. Maybe you want to repeat it a few times. Maybe, do you want to put 5 minnows in a tank, or is 500 better? It's always better to have more, right? Your sample size being larger is always going to be better. But again, we're not looking for a cookie cutter answer there. There's not like a range of values that we want to see. It's just, have you communicated to us as readers that you understand how science works and you've got a reasonable protocol that you're proposing?
Yeah, I agree. The thing you guys you have to keep in mind is that you're going to be limited in your time. So if you go into super detail on, parts A, B, C, and D, then you might not make it to E, F, G, and H. And so you need to think about that. You need to be specific, but don't spend all your time on the experimental design you know, trying to get it just exactly. I mean, you want it to be right, but if you get too nitpicky on your experimental design, you probably will miss points on the rest of the question. The College Board has told us that they do not expect students to finish. These questions are long, so don't freak out if you don't finish, but make sure you prioritize your time. Please keep the timer on your screen. I know it's going to be kind of nerve-wracking, but keep it on there. It's going to help you, because it's going to help you say, okay, I spent 3 minutes answering just part B. I need to move on to the other points.
Yeah, that's very important. If those of you that have had a chance to look at the videos that came out earlier, or yesterday and today, going through practice questions for FRQ 1 and 2, you'll have noticed the experimental design questions there, where the points were available. In previous years, like the 2012, the last one we've had, there was, you know, there was a concentration of points in the experimental design part. But on this latest version that we've seen, these practice tests, for that question 1, the setup was just 1 point. It wasn't 3 points. Hypothesis, 1 point. So yeah, you don't want to be writing paragraphs and paragraphs going into endless detail on what you're and how you're going to design this. It's probably only going to be 1 or maybe 2 points. So don't waste your time on that. And as Kristen said, yeah, the College Board has made it clear these are going to be very dense questions for both number 1 and number 2, because they want to give students as much opportunity as possible to earn points. So you might be totally stuck on something and think, man, I'm not going to get that point, but there'll be other points elsewhere that you will be able to get. So don't freak out and panic if you get to that 25-minute mark and think, I've still got 3 questions to go, I'm not ready. Don't go right up to the last second and use that final 5 minutes writing and writing and writing. It is far better for you to make sure you've attached and uploaded, or you've copied and pasted, or you've photographed and uploaded and have submitted before that time runs out, because it would be a terrible waste to keep typing, and then not meet that deadline for submission, and then all of that work counts for nothing. Don't let that be you.
Yes. Just a reminder that you can, even if you don't finish, just upload what you. The worst thing that you can do is not upload. Okay, that's you push come to shove, you need to upload. The other important part is remember that you can answer the portions or the section. So just label your section D, then A, then B, whatever it is.
That's a good point. Yeah, I see a question in the chat here, which is nice. It says, with a natural experiment, is it a good idea to specify that it could be conducted over several years so that seasonal change could be accounted for? I mean, it would depend on the scenario, but again, is that reasonable, right? If the question is asking you to design a long-term study to show, changes in some plant population due to, maybe you're trying to identify evidence of climate change or of the change in range of species due to increased temperatures, then yes, that would be reasonable. But if they're just asking you for an effect on minnows in a pond on fertilizer, I'm not sure it would be scientifically reasonable to expect that this would be a study that would go on for many, many years. It's just a direct cause and effect. So again, it's just a case of analyze the prompt and look to see if it's, what would a reasonable response be to the scientist. All right, let's get a look at this sample here before we get on to question 2. This is just it's an air pollution sample that's a kind of modified from some of the earlier practice questions you've seen. And so here we've got data from Italy. We've got researchers that have measured levels of tropospheric ozone, and they want to know what is the association between air pollution exposure and dementia. And so they're kind of tying this exposure to these particular chemicals to cases of dementia by address. And then they look at the hospital records, see who complained or had symptoms. So this is a sample where instead of having to design a study, you're being given the study and you've now got to identify what were the components of this experimental design. So let's see if we can identify the independent variable. So that, remember, is the thing that is being changed, right? What is it that is causing the effects that we're going to measure? The effect that we're measuring would be our dependent variable. That's the thing that is responding, that we're interested in seeing, is there an effect? Think about what the controls would be, what would be a control group, and then what things would have to stay constant, and then let's come up with the hypothesis. So let's first of all talk about the independent variable. In this study, go ahead and put in the chat, what do you think the independent variable is likely to be? Pollution level. Okay. So again, you may need to specify which of those pollutants are we interested in. Maybe we're going to measure, going to focus on ozone. Maybe we're going to focus on particulate matter or NOx. Or maybe it's all three. But if you can provide more detail, it's always good to provide more detail. Pollution level. Go ahead, Kristen.
You need to think about is what determines the amount of pollution, right? Did they just expose these people, or did they? What determined the amount of air pollution?
So we had a dependent variable, dementia. Yeah. So I guess it would be just, is it the presence or absence of dementia? Are we looking at sort of, is dementia concentrated in addresses that were exposed to more atmospheric pollution? That's a good response. Dementia would be good. What about then what would a control group be? What are we going to compare this research data with? How will we know that pollution could be causing dementia? What do you think? Somebody put into the chat there. What do you think a good control group would be here? What would the control group be in this study? Yeah, question here. Would I've not gotten the Go ahead, Kristen.
I think that maybe, Matt, if you could go one slide, I think that we're missing, right? The independent variable here, the thing that the researchers manipulated was where the people lived, because the address is what determined what they were exposed to. So the independent variable was what they were exposed to, but that was really had to do with where they lived. Does that make sense? So if you had just said the independent variable was the air pollutant, that's probably not correct. You needed to go further and say that the independent variable was the amount of pollution that they were exposed to based on where they lived. And then that dependent variable was if they got dementia or not. And then, like Sarah says, the control would be an area that did not have any air pollutants. So an area with low amounts of air pollutants. And then constants.
And again,
constants.
Go ahead. Yeah. So you would want to know.
Right. And so.
Sorry, we got a big delay here happening.
Oh, sorry. And so then, Robert, I think you're confusing a constant and a control. Remember that a constant is something that we're going to keep the same. So we're going to keep the same as, are you going to compare 5-year-olds to 80-year-olds? Well, 5-year-olds don't get dementia. So a constant is something we're keeping the same throughout. A control is, like Quinson and Sarah said, an area that has normal conditions, an area that doesn't have any air pollution.
Yeah, and so you're going to want to measure the levels of dementia that exist in those addresses as well to compare, because that's the only way you're going to be able to prove or support the idea that there is a relationship between these two. And so let's talk about that, right? That hypothesis. Let's think about what was the hypothesis that this research study was testing. Let's come up with a statement that would identify the two variables we've talked about and predict a relationship, right? So let's go ahead and put that in there. Go ahead and put that in the chat.
Somebody brought up a good point that our control is being normal conditions. Well, we don't know what normal conditions is. You probably need to specify it. You would say normal conditions for air pollution. And so that's a good point that as a reader, we see a lot. Well, it's this. Well, I don't really know what that is. You need to be very specific. A control group could absolutely. Allison asked if a control group could be the average number of dementia reports over a year for many different locations. And that could also be a control group. Like Matt said earlier, there's not a right or a wrong. I mean, there are right and wrong answers, but there are any number of right and wrong answers that the reader will be accepting.
Yeah, there'll be lots of opportunities for you to earn your points here. But with the hypothesis,
so
let's see if we can identify. Well done. If people, here's one from Skurla. If people are located in a place where NOx is abundant, then the amount of dementia and exposure to air pollution would increase. Okay, so we've got two things going on there. We've got you have identified these two variables that are in here, but it kind of sounds in the way that that's written, where you've grouped the independent with the dependent, where the amount of dementia and exposure to air pollution are kind of grouped together there as an effect, whereas we want to separate them out and say, can we make a connection? But really, if you think of it as a question, it's like, is there a relationship between the amount of air pollution that people are exposed to and the levels or rates of dementia cases in those areas? Right? That's the question. So then we turn that into a scientifically testable statement. And so let's look at another one here. Let's see. As NOx, particulate matter, and tropospheric ozone increase, the concentration of people with dementia also increase. Yeah, I think that's a good one. That's showing you an increase in your independent variable. That's directional. It's increasing. And we're predicting an increase in the concentration of people with dementia, or the number of cases of dementia, something like that, will also increase. It's great. Well done.
Okay, I think it's great. Let's move. I want to just, we're about halfway done, so I want to make sure that we get into FRQ number 2.
Yeah, so in terms of these tips that we've got here, just remember to, we're going to share a document with you. You may already have clicked on it. That is a one-pager that shows you how to kind of click through all these things and score the most points that you can. But let's get on to question 2. So pre-response question 2 is, this is different, right? This is not where you're trying to pull apart necessarily an experiment, although it can have data. So you could have a data set and a graph that was from some study that was done. So don't kind of switch off your experimental design brain completely when you're on question 2, because you're still going to need to think scientifically in order to answer these questions. But this is where, yes, there'll be content. You're going to have to describe some environmental processes, but primarily what you're going to have to do is analyze a diagram, a model, a graph, and then you're going to have to make claims about that information. And you're going to have to, as always, there'll be problems that you've got to understand and propose solutions for, and then back up that proposal with evidence and reasoning, justify. So remember, this question is shorter, right? You've got less time. So that's where I think when you look at the practice questions that we've seen so far, they're very equal in size. I'm not sure if that's going to be the case with this, because the first question is 30 minutes, including your upload time. But then you've also got the second one, which is a lot shorter. So I'm expecting it's not going to require quite as much work to be able to do it in, but we shall see. In fact, they've said that they're going to shorten the type 2 question. So it won't look quite the same. It won't look exactly the same, but the skills that are being assessed will be the same. So you do need to know some content, and you will have to analyze some data, obviously, and that you've done tons of this throughout the year. You're going to have plenty of that. You've got to be able to not only figure out diagrams, they love throwing these weird pictures at you. You've noticed this if you've done some practice questions on the multiple choice and in FRQs. Every once in a while, the College Board will throw a really weird looking diagram at you that you go like, what on earth am I looking at? But just take a breath. There are going to be clues to how to solve this problem just by looking at that diagram. And then don't forget, you still have to have your problem solution brain switched on. You've got to wear that hat with you. You've got to always be thinking about the context of this question. If something's gone wrong, there's a problem, how could we solve it? So here's an example of one. Christian, have you got anything you want to add to this practice?
Yeah, just really fast. When you guys get a graph, and they're kind of funky, the first thing that I want you to do is I want you to kind of cover up the graph and to look to see, is there a title? Because sometimes that title will tell you information. And then or is there a y-axis? And sometimes they'll even put it at the top. So look at your axes and your title first and jot some notes down. Even if you're taking, and then write some notes down and then look at the center of the graph to help you figure out what's going on.
Yeah, it's always a good strategy. If they give you a graph, just take your time with it, right? There's this, gosh, what's that strategy from the biological curriculum studies? I²? Yeah, identify and then interpret. First of all, look to see what information am I being given. Don't look for trends yet, because you can fall into a trap sometimes when you do that. Take your time, First of all, just identify what is the title, what is the stem of the question before it. Often students skip right past that. What is on the x-axis and what are the units of that x-axis? What is on the y-axis? Is there a legend? Are there multiple lines on here? Once you've identified what information is on this graph, well, then you can begin to start thinking about interpreting it. But don't jump straight to interpreting, because you can often fall into some little potholes, some traps that have been set for you if you do that too soon. Don't jump the gun. But here is a question that's a good example of a data set where it's kind of an unusual looking thing. We've got this density on the x-axis, persons per hectare. Up the side, we've got the relative annual per capita petroleum use. So you got to think, well, what is that? Per capita petroleum use per year. And then you've got these different regions that have been set apart, the United States, Australia, Europe, and then East Asia and Russia. So this is very dense. There's a lot of information in this graph. And I think you can expect a graph like that, where there's multiple sources of information. They may not ask you about all of it. In fact, I can pretty much guarantee they won't. They will ask you to identify specific things on this graph and to avoid other things, because they want to know that you can interpret the data, and that's the skill. So let's get a look. So the questions being asked here were where you had to, describe a trend, for example. Describe the relationship between population density and petroleum use. So again, this is scientific thinking, right? This is identifying the relationship between two variables, one on the x-axis, one on the y-axis. And so you had to state this in some kind of terms, but notice, look at all the different ways you could have stated it. There were 4 different possible ways to identify that trend. And as long as you've clearly identified the trend, the language you use to do that is very flexible. We just want to know, have you clearly identified the directional relationship between these two? Kristen, you want to add anything to that?
Nope, I think you did great.
That's high praise. I feel good. Wait, why is this not changing? Oh, here we go. Wait, are we at the end? We are at the end.
No, are we really?
We're at the end of that particular presentation, yes. So let's just, while I switch screens, let's talk about what should we pull up next? You want to do the one, since we've only got about 15 minutes left?
Can we do the task verbs? Do you have something that has the task verbs on there?
I'm going to pull that up right now. Yeah, hold on. Let me just get out of here.
Perfect.
Go ahead and put your questions, if you've got questions, in the chat or down in the Ask a Question. While I'm switching screens out here, we will we'll do this. Let's see.
I think that's right. Let me look back at this graph really fast. As the density increases, per capita petroleum decreases.
Yes, that is correct.
Yes.
Okay, so you guys should now be seeing on screen this one page.
You need to like focus it in the middle.
Okay, hold on. Bum, 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 bum. Here we go. All right, how about that? Are we good?
Perfect.
Good, all right. All right, so these are these task verbs. Now, you've seen this from the CED. We just want to talk about these because this is gold, man. It used to be back in the day, up until this year. I mean, we were kind of fumbling around trying to come up with our own definitions of what does it mean for a student to identify something. But the College Board has gifted us with these clear definitions of what these task verbs mean. So you see the word identify. It means to indicate something. And occasionally, it can be a one-word answer. If there's a chart to fill in or identify the name of a producer in this food web, it doesn't have to be this elaborate explanation. Just get straight to the point, be real quick. So identify a property of soil, texture as a property of soil.
Identify is usually the easiest points for you to get. So try to answer the identify ones first. It's usually a good technique for you to read through, answer everything that you know right off the bat. Like if you can read and say, okay, and immediately I know what this independent variable is, and I know what this identify this claim, put that on there, and then go on to things that you don't know. Because what students tend to do is they tend to spend all their time trying to make up or BS an answer for something that they don't know. And then they lose time working on stuff that they were like, oh man, I definitely knew that. So make sure that you read all of the parts and answer the stuff you know first.
Yeah, there's a good question in the chat here about what if you wanted to give an example? Do I have to do that? Do I have to state specific things? And this is where you're going to have to look at the prompt very carefully. If all they ask you to do is identify something, then if it's a number that you're being asked to identify, then yes, you would have to be real clear about that. But for example, don't just give a range of values and say, well, somewhere between here and here. Be specific, like your example. If you're talking about the question that we just looked at, the graph with the population density of petroleum use, you could elaborate. If it said identify the relationship between, you could say the relationship between is inverse, or as population density increases, petroleum usage goes down, for example, blah, 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 blah. But if it's only asking you to identify the relationship, you're probably wasting your time if you elaborate there. And somebody chimed in and said, if you want to give an example, you can, but it won't earn you another point necessarily.
Usually, if it asks you to describe or to explain, that's when they're looking for examples or like an elaboration point. If they just ask you, what is the relationship? Make a claim about the relationship. Identify the relationship. It should be, I do not tell my students a sentence quota. Do not make sure you write so many sentences. Because what you guys tend to do is you write sentences to fill that, because that's what your teacher has often said. And then you write things that are incorrect and you lose the points that you did earn. So tell yourself, if it says describe or explain, you need to give an example or an elaboration. If it just says identify or make a claim, just one statement, one word.
Yeah, so if it said identify the trend, then just state that. But if it says describe the relationship between population density and petroleum usage, well, then you're going to have to elaborate a little, because when there's the word describe, chances are, and you can see it on the task verb document we're looking at here, it often asks you to identify, or it assumes implicit in the question is that you're identifying something and then you are explaining it in some way or being more elaborate with your description of it. So identify a property of soil, you could say texture is a property of soil. But if it asks you to describe a property of soil, well, then you would say a property of soil is texture, which is determined by the relative amount of sand, silt, and clay. That's a good comparison between these two task verbs, identify versus describe. And then explain, maybe it says explain how a specific property of soil, or explain how soil texture determines the health of the soil. Well, now you really have to often argue. This is where claim, evidence, reasoning comes in. And if you know how to do that, that's a very useful skill, because often with an explain, you are having to teach someone something. You've really got to pretend that the reader, as we're reading it, is we want you to teach us this concept or this relationship. Explain to us how this works. Assume nothing. Assume we don't know anything at all about this topic, and you go ahead and just tell us what we would need to know to understand how, in this example, how this property of soil determines its health. Explain that to us. Teach us. Back it up.
So one thing that I tell students is describe is to make a statement and then one elaboration point. That could be an example. It could be whatever you want it to be. Explain is making connections and talking about the relationship. Okay, A causes B to happen, B causes C. Therefore, A and C have this relationship. If it asks you to identify and you list that relationship, you're certainly not going to lose points, but you are not using your time efficiently. But it asks you to explain, or if it asks you to explain and you just describe, you're probably not going to get the full points. Usually, not always, but usually explain is worth 2 points. And so you have to tell us as readers enough for us to give you 2 points. If you can ask yourself, well, how does that work? Or why does that work? Or what else is happening? Then you haven't finished answering an explain question. I'm not going to give you sentence maximums or minimums, but you should be writing more with explain than identify, but don't write too much, because then you're wasting time and you might say something wrong. And then you'll lose the points you've already gained.
Yeah. Yeah, you got to play the game here. But this is where these task verbs are so powerful because they can help give you clues as to where the points are and also if you're running out of time, if you've only got 3 minutes, that may not be enough time to get and explain a couple of points, but it may be enough time to identify something or describe something. So just kind of manage your time. Notice with explain, this is where it's how and why, right? So identify and describe are really just give me the fact and then maybe describe it. Give me some details about that fact. But if it's an explain, you're having to persuade somebody how or why something is the way it is. Why would this be a good idea? Why is this bad? For example, the one that I always do with my students at the beginning of the year is we talk about, explain one negative environmental consequence of increased atmospheric warming. And so students will say, well, one negative environmental consequence of atmospheric warming is it can cause land ice to melt. Okay, why is that bad? Oh, well, it could cause sea levels to rise. Okay, great. Why is that bad? It could cause flooding. Okay, why is that bad? That could lead to flooding of coastal habitat or loss of habitat. Okay, now we've said why it's bad. So you often have to keep asking yourself this question with these explain prompts, is if it's asking you to explain or justify why something is the way it is, make sure you keep asking yourself like a 5-year-old, why, and finish that thought.
So we have a couple of questions in the chat. So
yep.
Scarler asked, do we need to make a connection back to the statement for an example, for an explain question? So yes, connect back to what we originally asked. And then Sarah wants, could you give us another example of a describe question? So maybe like describe the impact of industrial agriculture. Okay, so that would be a good describe. I would say, well, with industrial agriculture, typically farmers tend to use pesticides and fertilizers. Pesticides and fertilizers can cause an increased use in fossil fuels, which can lead to acid rain. Increased use of industrialized agriculture might cause increased use of antibiotics, which can lead to antibiotic resistance. That's a describe point. I'm listing an extra elaboration point there.
Yeah, so there may be a question like this: describe the process of integrated pest management. And so you describe that. If it says explain how the use of integrated pest management can have positive environmental benefits, well, now you've got to justify how, not only describe this process of IPM, but then justify, make a claim as to why it's beneficial over other ways of dealing with pests, right? So the describe is just be as detailed as you can in describing something, but you're not trying to persuade anybody or argue anything. You're literally just describing it as if you were giving something in a textbook where you're like, what is this? And you read a little couple of sentences explaining what something is. That's what that is. That's what describe is. Explain is justifying, arguing something. I'm aware of the time. We've only got about 5 minutes left, so I didn't want to kind of nip through these. Some new ones for this year are propose a solution, make a claim, and justify. Now, these have been here before, but not in this specific terminology. Propose a solution might have been in the past. Describe one reasonable step that citizens could take to reduce the amount of runoff from storm drains. Or, propose a solution could have been in the past. Describe an action that a government could take to reduce trade in endangered species. I don't know. So it's the same idea that you've seen before, but you're just going to make a proposal about how can we fix this. So this example that we're looking at here is to do with soil fertility. It might say propose a solution to increase soil fertility. And then with these, man, there are so many possible answers you could give here. But notice that when it says propose something, it's almost always going to be accompanied with a justify or an explain, which is, yeah, here's what I think we should do. But then you've got to explain, why do you think that would work? You got to justify. What reason do you have to think this might work? Explain it. Sometimes they may give you data, and you're going to have to use the data to justify why that solution might work.
So we have a couple of questions about proposing a solution.
Yeah.
Remember that
No banning.
banning something is not realistic. I mean, it is realistic, but like, we can't ban people to stay inside their houses right now, even though we know that coronavirus, is infecting a lot of people, right? We are going to advise you to stay at home. We're going to put a shelter in place order, but we can't just ban things. So banning typically will not earn you any points because it's not realistic. But you can say, I'm going to put in some pieces of legislation. You remember that in proposing solutions, you tax things that you don't like, and you provide subsidies or tax credits for things you do like. So that's a pretty generic answer that'll fit for a lot of things. How do you get people to use less fertilizer? Well, my uncle is a farmer, and let me tell you, he gets little advertisements, little newspaper clippings, and then literature in when he buys fertilizer that says, hey, don't put fertilizer when it's going to rain. Okay, so you can always educate people, but be really specific. Educate them on appropriate fertilizer use. You can legislate, like we're going to give tax credits to people that use under a specific amount of fertilizer, or we're going to tax people that use over a specific amount of fertilizer. A tax and a fine are pretty similar. You can fine people for things. Remember, though, that if you're going to talk about legislation, like we're going to pass legislation, cities don't usually legislate. The city of Dallas doesn't put out pieces of legislature, but they might encourage a fine. But states and nations, countries can put out legislation. I know that gets really nitpicky, but we have seen it in the past where students have said, oh, the city is going to pass a piece of legislation. Cities don't do that. But you could say that the city might fine homeowners that put fertilizer on their lawn right before it rains. Yeah. Educating people is always your go-to answer, but just make sure that you specify, what are you going to educate them on? Don't just say educating. I'm going to educate people on using fertilizer when it's not going to rain and the appropriate amounts of fertilizer.
Yeah, a good tip to think about when you're proposing a solution or you're going to come up with an action for somebody to take is to think, who is taking this action? And is it reasonable for them to take this action? Like, homeowners can take certain actions, but they can't make anything illegal. They can't enforce any rules or pass restrictions or anything like that. But what they could do is make consumer choices. They could be educated about something. So it's always good to think, who is taking this action? What can they do? Governments can legislate, governments can tax, governments can fine, but individual citizens can't do that. Neither can businesses and companies. So just be aware of who is taking this action and can they actually take this action? That's really a good rule. Right. Let's look at analyzing data.
We're almost done here. I do really fast. Matt, can you go up 2 seconds? I just have one statement to say about this. If it asks you for a claim and a justification, make sure that you use numbers to support your justification. So if it gives you data, that you are justifying it using numbers, especially see where it says qualify. So it went from 500 gallons of pesticide to 250. Cite your data.
Yep. Yeah, and that's kind of in here too. They're going to combine these things where they may ask you to justify something from the graph you're looking at, and that is going to require numbers. Don't give a range unless they ask you for a range. If it asks you to identify a value, then pick a point that's reasonable. And remember, there's always some fudge room with these questions. If they say, at which year did the elephant population go underneath 600,000? Well, maybe on the graph it's in between a couple of values, but just pick one. Don't say, oh, it's somewhere between the year 1980 and 2020. I mean, that's 40 years. Of course it's between those two numbers. We really want you to earn the point by identifying and just, buckle up your belt and, go big or go home. Pick the number, stick to it, and know that when you do that, as readers, we're going to be given a range of values that we're allowed to accept. Now, with a trend, that's different, right? That is a little broader. That's where you can be directional. But again, you should still use numbers. Describe the values and how they are changing over time, especially if it asks you to justify something or make a claim that's been backed up.
Tatiana, it doesn't really matter if you choose the first. It doesn't matter. You could pick any of them. Sometimes it might ask you to provide evidence. That's the same thing as saying, give me numbers to support.
Yeah. These are the phrases. You've used these before. I'm sure you've used these many, many times. I have a little a wall that I'm building, which is, it's like a gravestone that's RIP these words, and it's things like bad for, harm, affect, green, friendly, those kinds of words, impact. These are very general terms, and remember, to get points on this exam, you've got to be specific. So you can't say, oh, the exposure of this particular pollutant into the water will cause harm to fish. Well, what do you mean by that? Can we be more specific? It'll be bad for the environment. Well, what's the environment and how will it be bad? Always be specific to get those points. If you say it's going to impact something, how is it going to impact? Is it going to be good? Is it going to be bad? And what specifically will this thing do? So try to be as specific as you can. Those general answers that are very vague are never going to earn you a point. You've got to be clear.
Yeah, don't use the word good and bad. It's just never a good idea. You guys, this link, Harrison put the link for this document in the chat, and we've also linked it to the Fiveable. This is super good. I would print this off. If you don't have a printer, write it down. Or keep the tab open when you're taking the test. Just be really careful that you have made your own copy. I think that if it's shared amongst a bunch of people, then that could be a problem for College Board. So just make your own copy, write it down, print it off if you have that capability. You know, we're sitting right at 6:03. I can stay Matt and I can stay for more time and answer more questions that you have. Is there anything else on this document, Mr. Wells?
The only thing really is these kind of words to know. They'll often ask
those are good.
Like they'll say, look for these qualifiers. That's what these highlighted terms are down here in this box. Whoops, I don't know what I did just there. Something strange just occurred. Here we go. In this box here, right? These are really gold, because if it asks you for an environmental or an ecological consequence, first of all, look to see, is it a positive or negative consequence, or is it wide open, in which case you can answer in either direction. But you cannot talk about people or effects on human health or on the economy or anything like that if it asks you for an environmental or ecological consequence. You really have to imagine a world without humans if it asks you for an ecological or environmental consequence. But if it goes for an economic consequence, well, now we are talking about people, but it's specifically money and jobs. Even here, we're not talking necessarily about human health unless you directly tie it to the costs of health. Sometimes that can be an economic consequence. But generally speaking, if it asks for an economic consequence, the way you earn your points is thinking about who is going to make money from this, who is going to lose money, what jobs would be created, or what jobs might be lost. And you don't see it very often, but this very last thing where it says societal or social impact or consequences, this is where you're talking in more kind of general terms about people, culture. This is where the aesthetics of things can come in and how people feel about things. That's more general. It's pretty rare that you see that. You're much more likely to see these two terms. Just make sure you don't confuse them. If it asks you for an environmental consequence of pesticides, don't talk about crop yields, right? Don't talk about farmers losing money. Don't talk about anything that's to do with money, jobs, people, health. You've got to talk about animals, plants, soil, air, or water. Any other thoughts on that, Kristen?
Nope.
All right. Well, guys, I know we've gone over a little bit here. We want to stick around. Obviously, you're not required to hang out, but if you want to stick around and you've got some additional questions to ask, go ahead and put them in the chat, and we'll stick around for a little while longer. And unless, Harrison, we are required to close this down.
No, you're not required to close now. I just wanted to come say hi. Thank everybody for coming. Fiveable wants to thank NMSI for this partnership with the AP Readers, and we wanted to remind all of the live stream participants to go check out the NMSI AP Reader streams for all Englishes, maths, and science classes that we have up until this Friday. Make sure you check the calendar on our Instagram story, guys. Thanks.
So somebody asked a question, what about the slides talking about the exam questions, when or where we can download them? That I think is on AP Classroom.
Yeah, and I've also attached it. You should see it as one of the resources attached to this stream. It is a PowerPoint presentation called 2020 Exam Info from College Board. We didn't get to it today because we had other questions, but there's everything you need to know about the AP Environmental Science exam, all the logistics, the rules, what you can and can't do, how to upload, all of that stuff is on that PowerPoint. But yeah, you can go directly to College Board. It's a PDF document, the big one, but it's also there.
I think, Harrison, can you hook up with the
link? If you want to share that link,
the...
Harrison, you can do that. It's the 2020 exam info. Google Sheet.
All right.
Google Slide.
For the Fiveable people who are watching this on the Crowdcast app on your phone, I just linked the Fiveable stream page. Like, this is the place where you go, and like this is where you get your Olympics points for staying live in the stream. And that also has the resources right under the video if you scroll down. I can link the 2020 exam PDF PowerPoint thing in just a second.
Thanks, Harrison. You've been so great.
Yeah.
Thank you guys for doing this.
We love this. We are here to help you guys. Does anybody have any other questions that we can answer for you guys? Just drop them in the chat or drop them in the ask a question.
And this is the PowerPoint I'm talking about. If you are clicking on it, that's what you should see when you pull it up.
This is what makes you visit.
Thanks, Harrison. That's it. Yeah.
Sarah asked about when the questions would be graded by. I think Matt, we're grading. I think June 18th. So I would say that your questions, you will get your score reports probably normal time, middle of July, late July would be my guess.
Yeah.
Oh, Harrison says July 15th.
It is July. Yeah, the College Board did publish that day. But remember, your teachers will get your responses on May 26th. So you will have an opportunity to go over with them if you want to. Obviously they won't have a rubric. They won't know how it was scored or what score you might have. But if it's interesting to you and you want to do it, I'm not sure how I feel about those kinds of exam postmortems. But if you want to, your teacher will have your responses on May 26th. Sorry, Harrison, we were hearing your family there for a little while.
I love Harrison's family. Any more questions you guys have? I saw a couple of NMSI people I knew on there, Jim and Allison and Janelle. We appreciate you guys being here, being enthusiastic, asking questions. It really made it a lot better for us.
Yeah, you guys asked some excellent questions. And remember, all of this is available to you to go over later on, and just use those resources. And most importantly, practice uploading, copying, and doing all of that stuff. Make sure you do that with the device you plan to use. It's open as of yesterday. You can go to the College Board and start messing around with that and make sure your device works okay. A little dry run you can do. Give it a go.
Matt and Harrison, do you know the answer to this? Somebody said they had an issue attaching their Google Doc. Do you know what documents are available for attachment?
Yeah, no, so you cannot attach a Google Doc. What you have to do is download the Google Doc first and then attach it.
PDF.
If you're in a Google Doc, the best thing to do is to copy and paste it into the browser that way. And because it won't, if you just put a link in there for the Google Doc, it will not take that. You would have to download it into some kind of format that they will accept, like PDF, doc, text. There's a few others that they will accept, but no, a Google Doc won't directly attach. That's a good question.
Thank you.
Yes, and I wanted to remind everybody that I have an FRQ review stream tomorrow. We're going to be going over the 2019 FRQ questions. They're going to be edited a little bit for this year's exam, but I'll also make sure to cover exam logistics and the exam demo for all 8 students. Remember to keep getting Olympics points, keep competing, keep doing all of that stuff, and stay on Fiveable to study.
All righty. Well, I guess we should wrap this up then. This has been a good time, guys. I'm going to end the broadcast. Bye-bye, everybody. It's been wonderful having you on here. Thank you, Kristen. Thank you, Harrison. It's always great to work with you guys. See you again. You're a rock star.
Thank you.
Thank you.
See you later. Bye-bye.